Gallium is a silvery, soft metal with atomic number 31. It melts in your hand at just 29.9 degrees Celsius, showcasing its unique properties. This element is vital for electronics, renewable energy, and advanced scientific research. In 1871, Dmitry Mendeleev predicted EKA aluminum. Paul Emile Leckich de Boisbaudran discovered it in 1875, confirming the prediction. He named it gallium, for Gallia, Latin for France, honoring his homeland. Gallium was first discovered by Paul Emile Leckich de Boisbaudran in 1875. He identified it through spectroscopy. He named it Gallia, in honor of France. Its chemical symbol is Ga, and its atomic mass is 69.723. Gallium is a soft, silver-white metal, similar to aluminum. Gallium melts at 29.9 degrees Celsius, but boils at 2403 degrees Celsius. Gallium forms an unusual orthorhombic crystal structure when solidifying. With a density of 5.907 g/ml at 300 K, gallium is denser as a liquid than as a solid. Gallium's valence is primarily +3. Its electronic configuration is Ar, 3d superscript 1 degree 4s superscript 2 4p superscript 1. Its first ionization energy is 5.999 eV. Gallium is not found as a free element in nature. It forms crucial compounds such as gallium arsenide, GaAs, and gallium nitride, GaN. It reacts with air, acids, and bases. The alloy gallium remains liquid at temperatures as low as -19 degrees Celsius. Gallium's melting point of 29.9 degrees Celsius means it liquefies from body heat. Gallium exhibits exceptionally high surface tension. Gallium's unique properties enable the creation of brilliant, highly reflective mirrors and deformable actuators. Gallium forms a complex orthorhombic structure with 8 atoms per unit cell. Each gallium atom has one very close neighbor forming a unique covalent bond. This forms Ga2 dimers, which act as the fundamental building blocks of the solid crystal. Gallium is indispensable in the modern electronics industry. Its compounds, gallium arsenide, GaAs, and gallium nitride, GaN, are critical for high-frequency applications, optoelectronic devices, and photovoltaic technologies. GaAs is extensively used in microwave and millimeter wave integrated circuits. GaN is vital for high-power devices. Gallium is a critical component in multi-junction solar cells, preferred for specialized applications like satellites and Mars rovers. Copper indium gallium selenide (CIGS) panels offer a cost-effective and flexible alternative to traditional silicon-based solar cells. Triple-junction solar cells, incorporating gallium, are the primary power source for Mars exploration rovers. Gallium alloys are widely used in medical and household thermometers. Gallium-based liquid metals are explored for advanced cooling systems. Gallium is used to stabilize the plutonium phase in nuclear weapons. Research is underway on using gallium-indium alloys for novel carbon capture technologies. Gallium is a cornerstone of modern electronics. It plays a key role in advancing green energy solutions. Gallium's unique properties enable diverse and innovative applications. Ongoing research promises even greater impact in science, technology, and industry.